Welcome to ePathshala lecture series on computer science. So this paper is about visualization techniques, and in today's module we are going to look at the various data principles associated with visualization. The learning objectives for today's module is to introduce the types of data, to learn the different types of data visualization in various aspects, and to learn about the data visualization principles, and finally some of the examples. We'll also look at some of the examples of data visualization. So what is data visualization? Data visualization, as already said, it is a visual representation of data for exploration, discovery and insight. If an interactive component can also be added to data visualization, where this interactive component can provide more insight as compared to some kind of static images that are shown to the end users. The language associated with the data visualization is, data visualization can be forming a sign system. There can be marks, and each mark on the visual represents a particular data element. The mark can be in any form. The mark can be a point, a line, or it can also represent an area. We need to choose the visual variables to encode the various relationships between the data elements. Some of the relationships that exist between the data elements are the difference relationship, similarity between two types of data, the order and the proportion. So, position alone will support all these kind of relationships. There are a huge range of alternatives for data with many attributes. That is, we can find images that express and effectively convey the information. This is a data type taxonomy. The data can be divided into various types. The data can be a one-dimensional data. The data can also represent certain temporal values. The data can also represent two-dimensional or three-dimensional attributes. The data can be an n-dimensional data. The data can be represented in the form of trees, networks, and the data can also be in the form of text and documents. So let us see one by one data in detail. This is a one-dimensional data visualization. Histogram is a very good example of one-dimensional data visualization. Histogram is an example for one-dimensional data visualization. Histogram usually show the distribution of values of a single variable. We divide the values into bins and show a bar plot of the number of objects that are present in each bin. The height of each bar in the histogram indicates the number of objects present in that particular bin, and the shape of the histogram depends on how many number of bins we consider. So here is a good example of a histogram. So there are various bins we can see. The height of each bar represents the number of objects that belong to that particular bin. The next one is a temporal data visualization. In temporal data visualization, the temporal visualization analysis refers to the process of looking at or analyzing the features or data that are dependent variables where time is an independent variable. So here actually in temporal data visualization, the data as such can be represented as a time series data, and the values varies with respect to time. So here are two different examples of temporal data visualization where the data varies with respect to time as such. So the temporal data visualization can take many different forms. It is the reconstruction of the spatial path as a feature that travels. It can be considered as a reconstruction of the spatial path as a feature that travels over time. It can be considered as the rate of change of velocity, the size or other data or factors that varies over the time, the absolute changes in the data fields that varies with respect to time, and the change in features that varies with respect to time. So these are different types of temporal data wherein the value of the data varies with respect to time factor. Next is an example of 2D data visualization. Here it is the representation of two sets of relative data. As such, the two sets of data entity can be represented in the x-axis and the y-axis. There are many kinds of representing this kind of two-dimensional data. These can be represented as a bar chart, these can be represented as a pie chart, a bubble chart, etc. Here are two different examples of two-dimensional data visualization. Next one is a 3D data visualization. In 3D data visualization, we need to understand the forms in a data with respect to x and y dimension of the plane, and there is a variation in the z dimension. Usually this kind of z dimension is represented in the, as a depth information associated with the objects. So in this case we need to represent the entire data with respect to three different axes, that is the x, y as well as the z axis. The correspondence between the data and the image with its level of perception is required to be objective in nature, and the visualization of the image can be mobile or it can be immobile also. So this is an example of a 3D data representation. So you have the x and the y axis, along with it we have the z axis details also. So we have x axis, y axis and the z axis details. Next one is a n-dimensional data visualization. In n-dimensional data visualization, there are n number of dimensional visualization for a given data set. It is the other name for n-dimensional data visualization is multidimensional data visualization. So here are given two different examples of n-dimensional data, wherein there are various attributes associated with the data with respect to the place of the data, with respect to the name of the data, with respect to the location of the data and all these things. So these are represented as n-dimensional data. The next one is the networks. In the case of networks, things are more likely to form groups, and if the groups appear familiar or meaningful to each other. We tend to group objects that are going to appear familiar or that appears to be meaningful to each other. We tend to form them in the form of, we tend to combine them in the form of groups. So connecting and grouping the similar set of data forms a particular network. So these are good examples of network visualization. The other kind of visualization is the text and the document visualization. Here in the case of text and document visualization, we try to completely integrate words, numbers, images and diagrams to show different modes and not get locked into only one way to see the evidence. We try to bring all these together in the text or document visualization. The text can be in the form of the name of the author or the name of the code modules. The text can be, it can also show some dependency information as brackets and things like that. Images can be used to tell the granularity of the information, and we try to integrate all the entire dependency text as such. So this is text or document visualization. So we can also see that the types of data as such can be broadly classified as tabular data, ordered data, it can be relational data, or it can be some kind of spatial data. In the case of tabular data, we can once again divide the data into two different types, that is categorical or nominal data, or the data can be in some ordered format. In the case of categorical or nominal data, nominal usually represents names. We try to represent them by names. So for example, male, female is a good example of nominal data set. Similarly, there can be different categories like AA, AT, AG. These can represent different data set, categorical data set as such. The other one is the ordered data set. In the case of ordered data set, we can have ordinal data as well as quantitative data. So good examples for ordinal data are abundant, common, rare. This is one example of ordinal data. The data which is represented in certain order. The data set like the days of the week, say Monday, Tuesday, Wednesday, etc. That also forms an example of ordinal data set. In the case of quantitative data, we need to represent the data with respect to some quantitative values. So 10 millimeters, say for example, we try to represent the rainfall in a particular location. So we say 10 millimeter, 15.5 millimeter, 23 millimeter. All these are good examples for quantitative data type. The other type of data is a relational data, where there exists some kind of relationship between the various data attributes. So examples are trees and networks are good examples for relational data type. The other one is a spatial data. In the case of spatial data, the entire data is represented in the form of a map. where the attributes are represented in the spatial region as such. So this is a broad classification of different types of data as such. So when we talk about the data, we need to have a clear vision of the data. That is, we need to make the data stand out in our visual. We try to use visually prominent graphical elements to show these kind of data. When we try to use visually prominent graphical elements, we should not clutter the data region as such. We need to use a reference line when there is an important value, and that must be seen across the entire graph, and we should not let the line interfere with the data set. So whenever we need to stress something or important points, we can use the reference line, and this should be seen across the entire graph, and we need to see to that this does not interfere with the data as such. And we should not allow data labels to be present in the data region, so that they may interfere with the quantitative data value, or they may clutter the entire graph as such. Next, in the case of clear vision, we also need to look at avoid putting nodes or keys or markers in the data region. The region wherein the data is being represented has to be very clear. We should not clutter the region by including nodes or keys or some kind of markers inside the data region. So in that case, we need to put the keys and markers just outside the data region and put the nodes in the legend or in the text. We need to see to that the overlapping plotting symbols must be visually distinguishable. If there are any kind of symbols that needs to be overlapped, we should see to that they should be visually distinguishable. And similarly, superposed data set must also be readily visually discriminated. There should be some kind of visual clarity that must be preserved under reduction as well as reproduction of the data set. Next one is clear understanding of the data. See to that in our visual, we just on looking at the mark, or by just looking at the visual, it should be possible for the end user to clearly understand what the data is. So for which we need to look at certain aspects, that is, we need to put major conclusions into graphical forms. We need to make legends more comprehensive as well as informative. The error bars should also be clearly explained. We need to proofread the graphs, and we need to strive for clarity in this case. The next one is with respect to graph. In the case of graph, there are a large amount of quantitative information that can be packed into a single region. So here given are the examples for graph data type, graph visuals. So here the graphing data should also be an interactive, and it can also be used for experimental purposes. The graph data 2 or more times must be used whenever it is needed. We need to use many useful graphs that require careful and detailed study. When we talk about the data visualization, we need to look at 8 different principles of data visualization. They are as follows. The first principle is we need to understand the problem domain as such. The second one is we need to get the sound data. Third is show the data, and also we need to show the comparisons very clearly in our visual. The fourth principle is we need to incorporate various visual design principles which we have already seen in the previous module. The next one is we need to add small multiples which tries to make the data more complex. Then we need to add certain layers to the visual. We need to add access or coding patterns to the visual, and we can also combine certain metaphors in the visual. So these are considered as 8 principles of data visualization. So let us look at one by one principle in detail. The first principle is understand the problem domain. So in this case, if you are producing a visualization for your own use or for your department, that has to be considered first. So we need to look at whether the visual that we are going to produce, is it for our own use or is it for the department or for some other person. So then the chances are good that we already understand the area that we are working in. But in reality, there may be other cases like visualization has to be done for other department or even for some external stakeholder. So in such cases, we need to ask the questions to the stakeholders, and we should also do more research in understanding what is the data and what is the problem domain that is associated with the data. So in understanding the problem domain, clearly we need to look at whether the visual that we are going to create is for our own use, or is it for some other stakeholder, or is it for the department in which we are working in. If it is for our own use, then there is no problem because we already know what the data is and what it is going to represent. If it is for some other external stakeholder, we need to see to that we understand the problem more clearly or do certain research to understand what is that is involved in that particular data set, and then we try to create the visual. Next one is get sound data. This may seem obvious, but good data is at the heart of any effective visualization. Whenever we say that some visual is more effective, it means that looking at that visual itself, it should be possible for me to get the exact data as such. So for creating a visual of that type, we have to make sure that the data we select is as accurate as possible. And we should have a sense of how it is supposed to be gathered and what errors or inadequacies that exist in the collection of that particular data. We also should make sure that we get the relevant data and we also get enough data out of it. So using these kind of the relevant data and the accurate data, we need to create an effective visualization, which we should see to that it needs to be understandable and meaning of the data has to be provided to the end user. This can be a challenge if it has been stored as raw numbers as such. So this is the principle behind getting sound data. Next one is showing the data and showing the comparisons. So picking the best type of visualization is an art basically. There are various types of visualization that exist to represent the data in the visual form. So we need to pick the correct type of visual form that will suit that particular data set. So in selecting, the basic rule of thumb is to choose a spatial metaphor that will show the data as well as its relationship. So with minimum distractions or efforts on the part of the viewer. We need to see to that when we are choosing the spatial metaphor, we should see to that there are minimum distractions or less effort on the part of the viewer, so that just on looking at the data, it should be possible for him to compare it with some other data set. So in the case of network, the network visual can be used to show some kind of connections, or sometimes in the case of radial layout, the network visual can be used. Linear visual is used to show how something varies over time or something varies in relationship to another factor. This can be represented often on an XY space. Sometimes the data can also be represented in a hierarchical manner, which can be used to show groupings and importance, and these can come in many different layouts. In the case of parallel, it is used to show the reach, the frequency or shares of the whole that can come from many different layouts. The next principle is incorporate the various visual design principles. So already in our previous module, we have seen the various design principles with respect to say symmetry, shape, rhythm and all those things. So those are to be considered while creating the visual. So usage of sound visual design elements like line, form, shape, value and color is to be understood first, with the principles like balance and variety to make a visualization in both inviting and easier to read for trends and comparisons. So this will be very particularly important when we take our linear metaphor visualization to the next level. If it is in the form of a linear metaphor visual, it is easier for us to understand. Whenever we take our linear metaphor visual to the next level, whenever we try to make it more complex or compare it with some other data type, we need to incorporate some kind of balance, we need to incorporate some kind of variety into the visual that we create. So in such cases, we should see to that we incorporate the various design principles as such. The next data principle is bring in more dimensions. Once we have the good data as well as the sound data, then we need to look at the underlying spatial metaphor, and finally it is time to take the account of complexity of the data type. So we need to consider the various dimensions of the data and see to that all the dimensions of the data and its associated attributes are explicitly shown in the visual. That needs to be clearly considered. So based on our knowledge and research, we can also come up with the initial look at the simpler linear metaphor visualization. So examples are store sales. We can consider store sales as an example. In this case, how is it possible for us to bring in more dimensions? How do we know that this upstick in sales is not just a seasonal trend? We can also look at total sales are up, but has a new store layout succeeded in improving the performance of some of the departments that were struggling before? These are certain questions that can be answered when we try to bring in more dimension into our example, that is our store sales. We can also look at, are we succeeding in getting more customers into the store or not just selling more to existing ones? Are customers shopping more departments and buying a more diverse mix of items? So these kind of questions can be answered, and answers for those questions can be got just by adding more dimensions into the linear metaphor visualization in the case of a store sales example. So asking these kind of questions is a great exercise to begin talking about taking a very good visual. This will lead to the next level because they may prompt us to add more dimensions. That allows more viewers to explore and understand the subject. In addition, we can also add more angles and add in more details also. There are a variety of solid techniques that can help achieve these kind of additional dimensionality. The next principle that we need to look at is add small multiples. As a small repeated variation of a graphic side by side allow for a quick visual comparison. So whenever we try to add small changes into the already existing visual, that may help us in grasping a lot amount of information and will also help the end user in having a quick visual comparison also. So in that case, whenever possible, your scales should be kept at the same and the axis of comparisons are supposed to be aligned. So in the case of visual comparison, we need to see to that the scales should be kept as the same in both the figures, and the axis of comparison should be aligned to each other. So adding some small or stacked thumbnails to the chart or to the main one allows a comparison of sales trends and for the one that exists previous and for the one that exists now. So like that we can also add certain multiples and try to compare it with the existing values. The next principle that we need to look at is adding layers. So we can also add extra levels of information while also preserving the high level summary data. So we try to make a graphic representation more flexible and useful in that way by adding different layers. We are also going to break down the top line of the total sales into departments in the case of the example that we have considered. So the resulting stacked area chart shows the sales from the appliances department, and we can also see to that the sales has increased in the appliances department. As a proportion of the whole, but media department sales have not improved much. So as a whole, it can be understood that media department sales has not improved as such. So thereby, by adding different types of layers, it is possible for us to compare across different departments. Next one is adding access or coding patterns. Another way to get more dimension in a graphic is to add additional patterns for the coding information, such as we can vary the shape or color of the points on the plot based on a particular variable, or an extra axis in space can be placed alongside an existing one, or it can be kept in a new direction in the case of a 3D chart. It can also be useful for showing new variables. So it is therefore important to be careful with this approach as it can add clutter, but when used sparingly and with good design principles, it leads to a very good visual as such. It can also increase a graphic usefulness. So according to this principle, it is possible for us to add extra access to the already existing visual, and we can also add or change various coding patterns as such and see to that it adds certain extra information to the visual that we have created. The next principle is combining metaphors. It is also possible for us to combine various metaphors. So far we have seen a linear metaphor for our visualization, which is a spatial metaphor as such. So if we want to add a network metaphor to show the connections between the product categories and purchases, so in that case it is possible for me to combine both the network metaphor as well as a linear metaphor into a single visual as such. So a pair of circular relationship or a chord diagram is being considered, which shows the snapshots at the beginning as well as the end time period, and can also help compare these kind of connections. So like a pie chart, each product category is assigned a section of the circle, and by percentage of total sales, and the center of the circle is represented as an hollow. If the majority of purchases containing items in one category also included items in the second category, a line is drawn to the second category, and the line width is based on the average proportion of both categories in the case of mixed purchases. So this is a kind of example for the chord diagram that we are talking about. So here the increase in these chord lines from the first to the second diagram suggests that these are indeed more purchases that cross departments since our initiatives went into place. So this relationship data would be even better if we would like to see it at any chosen point in time. For example, to see what effect, what if kind of analysis can also be performed over this kind of chord diagram. As our graphics increase in complexity and sophistication, we need to think more carefully about how to deliver effectively the kind of data that we have at hand. So this is a good example for combining visual metaphors. So in the next final principle is considering new delivery methods. So we need to look at different delivery methods for effective delivery of the visual that we have created. So the point of any visualization is that it is supposed to be viewed by the right people in the right context. So some of the few examples we would enable through timers, through time are drilling down and zooming out for a bird's eye view, or seeing new data live as it becomes available, or even manipulating future variables to watch different scenarios. The next one is 5 principles for creating effective data visualization. Be open to discovering new insights. Effective data visualization enables the user to discover unexpected patterns, and it also invites a different perspective of the data. The next one is think big but start small. Users needed quick solutions to a very painful process that was costing time and lost business. Next one is design for the user. User journeys and prototypes help to define the user goals. Prototype to identify the needs. A small cross-functional team to be set out to find a solution based on some 3 kind of questions. Will the customers use it? Can we build it? Does it meet the business needs? So based on this, a small prototype can be built to identify the needs of the customers. We can also obtain feedback early, and often the feedback can be got from the end users. So these are certain examples of visuals that are being created. The color that dominates. Here it is difficult to distinguish various data sets. Here it is murky because each and every data set overlaps in this case. These are browser colors. Recolor, the previous data is recolored with brewer palettes. This is example of sortable table and matrices. So in summary, as such, in this module we have looked at the different types of data. We have looked at what data visualization is. We have seen at various data visualization principles, and we have also looked at certain examples of data visualization. Thank you.